Okay, cool. Welcome back to another round of APOW. I'm sorry that I haven't been posting much, but we're back. We are back. I said I would post it by 2025, but it's okay. It's first and it's not too late. So today we'll be going through problem set 3, which actually has a lot of avoided questions, I would say. Anyway. The thing is, okay, honestly, I would start with the latest APOWs, but the thing is, right, the problem sets 1 to 3, they don't even have any data, like there's no solutions at all. If you look at the past set solutions, which is in fact public, it should be on the website somewhere, but problem set 1 to 3 has like no solutions whatsoever, so I guess it's still necessary to at least make some videos talking about them so no one gets confused. But yeah, let's get into it. So question 1, a telescope has focal ratio whatever, so what's the resulting magnification? So we see this focal ratio of f10, so aperture of 7, so the actual focal length is, or should I say FL, is equivalent to, which is 700. So if you take IP to 14 nm, so the mag, and then there's a 2 times power lens, so actually it's 2 times 700, wait, and then divided by 14, wait, this is a mess. So it's 2 times 700 divided by 14, which guess what? It's just 14 times 100 over 14, which is 100. So the answer is in fact C. And as for question 2, oh shit, oops, accident. So what's the Roche limit? This one is just a definition question. There's not much to say. The answer is D. Oh, you're not straight. That's not very nice. And for question 3, which one's more likely accretion disk? This is just this. A planetary nebula, the keyword here is nebula, alright? So it's not, even if there's a planetary inside, it's not it. A black hole would have, but once again there's no surrounding matter, so it wouldn't be accreting anything. A protostar would have accretion disk, because you know how protostars work? It's just a bunch of gas condensed. So they form the star, right? But it also form like other stuff around the star. So that's where the accretion disk comes from. It's not a black hole specific thing. It's a universe specific thing, I guess. And as you might know, the sun does not have accretion disk. So this one's just common sense, okay? So yeah. Next page. So I changed it to like portrait because why not? But yeah, question 4: what happens when a comet approaches the sun? Yes and yes. The phrasing for this is a bit weird, but the gist of it is correct. Because it's gonna point away from the sun because of the way the comet works. You see here is a comet and the sun's like all the way over here, which you can tell even without looking at the tail because you see the sunset, right? So yeah, so the sun here, let's make the sun orange. There's the sun here, right? And the comet here, and it's pointing away from the sun. Because when the solar wind, right, it will push the stuff away. But there can actually be an anti-tail. An anti-tail is basically a tail that points, in fact, towards the sun. So it will look something like this, you know, actually points here. Even if the sun is here. Which might seem counterintuitive and might scream aliens or whatever, but it actually isn't. The anti-tail is in fact a dust tail. This one's irrelevant to the APOW, but like yeah, this is a dust tail. It's never a gas tail. Because gas tails are too light, they will definitely be blown away by the solar radiation. So this is a dust tail, and it's called an anti-tail. And this happens because the stuff, the nucleus of the asteroid, let's get a nucleus. So the nucleus of the asteroid, right, it has dust and gas, obviously, so the gas and whatever they're sublimed, the dust, whatever, will get ejected. And when the dust gets ejected, if the asteroid is such that the dust gets ejected at like a fast enough rate, it will actually first spew out, you know? Because normally what happens, like how this happens is that you have an asteroid, right, the nucleus, and then you have the sun. The sun is doing solar radiation, you know? All the photons and whatnot, so it's hitting the asteroid. So as it ejects the dust, it actually goes back, right? And because they generally go back, you don't see the front. It's not very visible. So what you end up seeing is just the net effect of the tail, which is what you see that points away from the sun. But if it ejects the dust at a fast enough rate, it will actually just come here first, you know? It just come here first before getting blown back. So that causes an anti-tail, which is, I think it's a pretty fun fact. It's a pretty cool fun fact. And in fact, if you've heard of, there's a new comet, Triae Atlas. It's the third interstellar comet, which is why there's a Triae, you know, the third interstellar. Atlas is the observatory, the telescope, whatever that found it. And it has an anti-tail. It's very pristine and all that. But yeah, if you're curious, you can check that out. There's good videos about it. And no, it's not aliens, despite what the Harvard researcher might say. There's T, yes, but no, it's not aliens. Anyway, okay, so that's it. The answer is C. And this, wait, coma, diameter of the coma, wait, hold up, coma, wait, am I getting my comet shit right? Coma, media, labeled, give me a 5 minute, I'm a bit confused. Coma, oh, the coma is the nucleus? The coma is around the nucleus? Atmosphere around, okay, yeah, okay, I'm right, okay, good. Cool. So yeah, this is intuitive. This is also sort of intuitive, therefore it's all of the above. Just a bit of a weird phrasing. Like direction of comments of it. I mean, this is also kind of intuitive, but normally we just say it just points away from the sun. Because the tail wouldn't happen, you know? Like if the tail wouldn't happen if it's not close to the sun. If you get what I mean. Because the reason why the tail happens is because the sun is shining on it, causing it to eject material. So if there is, in fact, no sun, there will be no tail. So it also wouldn't be pointing in the direction of comet's orbit. But hypothetically, if there's some other light source that is not the sun, that is also not very powerful enough such that it, actually no, it doesn't make sense, but like basically this part I, in my opinion, is phrased slightly weird. I was only setting for like APOW like 5, 6, 7, 8, I forgot, like maybe 7 or 8 onwards, so everything in front of here I've actually never seen or done because I only did like APOW from like 3 onwards, so like 4. But yeah, the phrasing's a bit off, but it's okay. The gist of it, the knowledge is the same. So yeah, do what you will. And for question 5, so we have a star, luminous blue variable, cool. This one's just another theory. So this one is this. Let's do it by elimination because like this is the answer. Like this is the answer. Why am I drawing question mark? But like the rest is wrong for reasons. This is not the issue. Like yes, there are many stars in the line of sight. This is correct. However, they're all tiny and honestly, like it's not that big of an issue, and it does not explain why it can be observed in infrared. Like look, if there's other stars in the line of sight, you shouldn't be able to observe like anything or like resolve anything, you know? Like it doesn't make sense. Like basically the link isn't there. So no, it's not B. And ionized hydrogen. The keyword here is ionized hydrogen. Like ionized. Because you know what happens when it's ionized? It doesn't absorb shit. When it's ionized, it emits stuff, which you might learn if you learned emission and absorption spectra, but basically when you're ionized, you're emitting light. It's only when you're in a ground state, so when you're like neutral, when you're like chill, then you can like absorb stuff. And also, this is also not true because the ionized hydrogen is actually only going to absorb specific wavelengths. It doesn't explain why it would absorb stuff shorter than infrared. Like in fact, there are like lines of hydrogen that is in the infrared. Let me hydrogen line series. I forgot what it's called. Lyman? Is Lyman the UV one? Passion bracket. Yeah, Lyman's the UV one. So yeah, that's bullshit basically. And LVV is extremely hot. This doesn't make sense. The hotter you are, the more visible a UV you should be. In fact, both should be nearing UV instead of infrared. So this is just like a trick question, a trick option. But therefore it's A by elimination. And also A because theory says that it's A. Because the plane of the Milky Way consists of a lot of interstellar gas and dust. And this is what that causes it to redden. Because most of it interstellar gas and dust, and this one's more like scattering, you know? It's like how the sky is blue because the blue light gets like scattered more, but also why the sunset is red because the red light gets scattered less, so you get to see it. And in this case, the blue light's all scattered away already, so you're left with red. If you get what I mean. I think it's correct. I think it's the blue that gets scattered more. let me check. Relay scattering. Save me. Light. I don't think I need to specify light, but blue gets preferential scatter, right? Blue. Yeah. So you're left with the red light because the blue is like just gone. That's why. This one's an intuition question. Technically, I should do math. Theoretically, I should do math, but I don't want to do math because you can easily just use intuition. And number one, this is wrong. This is wrong because like there's no way you have a magnitude of 2.16 and somehow you're 4.95. That's just wrong. And this is too much. So no. So the more likely option is this. Take note that the magnitude scale is like 1 mag is like cube root 100. No, fifth root 100. Fifth root, I believe, 2.51. Fifth root. You know what? Let's just check it out. This one's for things. Is it fifth root? Is it fifth root? Yeah, it's the fifth root, so it's like 2.511 amount of times more. So, oops. So when you look at this, right, this is actually this. Or should I say it's 2.511 times brighter, and so at 4.16 it's another 2.511 times brighter, and right now we have like a 4.88. So let's just take it as about like a, let's just estimate, okay? Because for this question I'm not paid enough to do an actual calculation, but I also sort of want to give a more or less quantitative explanation on why it is not A or B but instead C. So here we are. So right now we already have like what, 2.511 squared, just like what, let's see, close to 5 maybe, close to 5, should be close to 5, my brain's not braining, oh no it's 6, I'm stupid. Okay, anyway, hilarious, so it's like 6 times brighter, so we have a total of like what, 7 units. But at the same time, if this wants to move up, right, like if this wants to move up, it still needs to be like that many times brighter than that. So right now what we have is like maybe about like 7 times brighter in total. So it's like 7 out of 6. 7 units over 6 units, which is, as you can tell, it's not a lot, okay? It's not a lot. So if we take like, what, 7 over 6, it's only like 1.166 times brighter. And note that to get to, say, 1.16, you need to multiply by this much. And as you can see, this is 1.1 something is like really little. So even if we take this, right, like we take this 1.16, and then we try to brain a little and we think, is this really going places? Like can you really make it here? I think not. I think not. Right, I feel like I just gave a really bad explanation. Give me a fair minute, I think I might just do the math. Okay, I might just do the math. I'm not sure if I need to edit this out because my brain's not braining. For information, I'm having like a fever right now, but like it's fine. Like if it explains why my last brain cell is not braining. Okay, great. We have like what, 2.16, 4.8. We're trying to find a resultant magnitude. And we know that each increment is like, so if one increment is 1 is by log that much, and that is basically split. Wait, what am I saying? You know what, let's do a quick Google because I'm not sure if I'm teaching the right stuff and I don't want to teach the wrong stuff. God, magnitude, scales, astronomy. Calculations. Please save me. Alright, great. 2.511 log. Okay. Sure, I will accept that. So basically we're finding a difference between some value, intensity, okay, in this case we're calculating like m1 plus m2. This log 10 is just that log minus, so it's actually like what, 2.511. But at 2.5 onences. Do we have to convert it to solar? I don't want to convert it to solar. I mean, the typical way to do it is you can convert it to solar. Wait, let me think if there's actually a better way to do this, because I really don't want to use my brain cells. Seriously? Yeah, if we have the magnitude of 2 stars, we can calculate the ratio of the intensity by inverting the equation. Where did the... Oh, okay. But I don't want to... Oh, wait, I can in fact do that. Wait, no, that's not exactly what I'm asking for. Can we just skip that question for now? Basically, I'm pretty sure it's C. By intuition. But whatever. And this one's just B. This one's just B. Because okay, like, Scorpius is here. Oh wait, the color. Come on. Scorpius is here. This is the tail. And as you can see, it's not in full. Sagittarius, you can see a teapot. But please keep in mind that, like, Sagittarius is more than the teapot. There's, like, other stuff in here, which is, like all the way, like, here or something. They're, like, over here. And it's not shown, so like, man, it's not it. But Corona Australis, on the other hand, it's pretty much all here, so yeah. A Scutum is all the way like over there, so it's not even here. Therefore it's B. 8. This one's phrased really weirdly. I personally avoided this one because, like what do you mean by angle between the two objects? Like what do you mean by angle? Like look. So I actually went to Stellarum, right? I actually went to Stellarum. If you can see here, I went to Stellarum. It's not showing now, but Arcturus, right? So Arcturus, and then if you fast forward all the way to like July, and then if we turn on the grids and lines, so we can actually see that it is in fact crossing the meridian. Okay, come here. So we need to change the timing a little to like around 8. I think you're a bit too high. Oh man. But where is... Bro, what? Huh? Give me a second. Oh wait, yeah, you have a declination of plus 19. Okay, never mind, my brain's not braining, I feel stupid. But anyway, yeah, we have it crossing the meridian, as you can see right here. And if you look at stuff like Lyra, or Vega rather, realize that this thing is like a 21, this thing's like a 72, and well, 70 something minus 20 something is 50. And then if we look over here and we try to find Spica, and like Gemini, Pollux, and Castor is like below, okay? So like they don't exist anymore for the time being. And Big Dipper is here. Am I blind? Am I blind? Hi. Here you are. This one's 71. And this one's like 72. So like I don't think this is it either. Like even if you look at out as, that's like 227. This one's like 355, and I don't think that's anything to do with like 60. Or this for the most part. Because this side that's like what, 50, so both are like 50 degrees apart, and the question asked 59, so like where did this come from? Like do you mean the angle like subtending, but with respect to what, like the north meridian? Like what are you referring to? Basically it's a very confusing question, therefore I'm avoiding this one, but just by eyeballing I assume the answer is Vega. I actually also don't have the answers for APOW 1 to 3, so it's just me smoking. So yeah. As for 9, this one is C. For you to become a roof riot star, right, the first thing you need to do is to like be a bit more massive than this. Like the minimum mass is like what, 20 solar masses. So first you need to be a bit, more chunky than this, and also the tech. There is a small chance that they might not even last a black hole, but anyway, 18 solar masses. I mean that's for even massive stars, but because this is not massive enough, so unfortunately we're going through the blue loop and going this way. This one's just stellar evo, so it's just something supposed to memorize. So if you get this wrong, it's fine. Typical. It's hard to remember. You're asking for not true. This is true. The redshift of nearby stuff, like large doesn't matter, the keyword here is nearby. You do not freaking measure redshift for distance for nearby galaxy clusters, like no. As for this, the fuck is the Doppler effect? I mean obviously I know what the Doppler effect is, but like I do not link these together, so the answer is just B, but let's see about the rest. This is in fact not a standard candle because type 1a supernova is a standard candle. And as for this, yes. If you subbed in D equals 1 over P, you'll actually get like, which is, but because it's 35 light years, so it's actually like more like 3.26 over 35, which is like half. It's like half of this, so it's like 0.09 something. I forgot the math. Like I forgot the exact value. But like if you think the phrasing, look at the phrasing. It will move how much? And if you look at the parallax is half. Last I checked at least. Parallax is like half the angle. So it's like this theta here. But then the thing we actually, when they say move, what they're finding is this angle. So it's like T2. And in this case, T2 is in fact twice of this. Therefore, this is correct. So given that A, C, and D are all true and B is untrue, the answer is B. So for question 11, this is another question that doesn't make sense. Like first, okay, like by far here makes sense. And then this is still making sense, but this is not making sense. Like, except Earth. So we're not using Earth? So are you asking me to sub in like what? Mercury, Venus, Jupiter, Mars? Like exactly what? Because you know, if you want to find the equilibrium temperature, you need a like even if they assume it's a black body, oh shit. Even if they assume it's a black body, right? You still need to do with like stuff like radius, because the radius affects your surface area, which affects, you know, the equilibrium temperature, because it affects the power that you're capturing and all that. So like, and they also say other planets, so I assume the other planets are significant, right? So in this case, like what do you mean? Like, do you mean them and where they are? So do I get to move the orbits? Like, are you trying to calculate if Mercury or Mars or whatever could have liquid water? Like, what? Or are you trying to say that no, they can't move, but in this case then the answer has to be just nothing, right? Like am I supposed to take like, say, Mars's like orbital radius minus, say, Venus's orbital radius and get like some value? Like what do you want me to do? What do you want me to do? And what do you mean by absorbs light and does not trap heat? Then where's the heat going? Because you have to, if you're not trapping the light, then you're emitting it, right? But if you only absorb light, then basically a lot of things don't make sense. So like I tried to do this and then I just stopped trying. But if we are in fact going by if we try to do it, right, like if given the limited information, if we assume a few things such that we're only going to use Earth as the reference point, and we're trying to calculate like how far you can move Earth, like, you know, here and there, such that it will still, you know, have liquid water, and then if you do that, then you're gonna take, you've got to first convert this 15 degrees Celsius to Kelvin, which is you know, something you need to recognize. If not, you're gonna get fucked. And as you might know, liquid water is from 0 to 100 degrees C, which in other words is basically 273K to 373K, which means that you need to do some stuff. So you just gotta do the ratios and stuff. Like, you know, gotta go like what? Because at first we were at 288, right? And then we're trying to like find it at 273. So we do this, and then on the other side we need to do this, and basically just find the percentage. And then we need to square root this, because remember the power emitted, the power received is inversely proportional to like the distance towards the sun or the, you know, the star. So we need to square root that, because the amount of heat received is actually, you know, yeah. And after square rooting this, we get some values, and last I checked, the actual difference between this minus that is like what? It's like 0.2 or something. 0.2 AU approximately. I forgot. You can do the math yourself. I forgot. I completely forgot. I could be completely off. But last I checked, it's definitely below it. It's definitely lower than A. So like, I don't know what's going on. So yeah, I'm avoiding this one as well. As for question 12, the phrasing is really weird for this one, okay? The phrasing is also kind of weird, like for the correct answer. But, the answer is B. Like, yeah, I guess. I mean, it's not wrong. For me, it's a bit weird, but it's more like personal preference. And, object located in constellation, in the constellation the shower is located, the southern meteor shower. I mean, yeah, you're not wrong for saying that. Like technically, yes, but no, because then in this case it should be happening every single time when a constellation rises, not specifically in that year. So A is out. As for C, yeah, they trail slightly behind the orbit and intersect the Earth. This is incomplete. It's not wrong, okay? It's incomplete. Because, yeah, trails behind object, like I guess, yeah, because if you don't trail behind object, we're supposed to go in front. So it intersects, which forms meteors, but it doesn't really explain the annual thing and the, you know, the same meteor showers repeating yearly and all that. It's not explained, so it's incomplete. As for B, its orbit intersects Earth, which is correct, since the ice and dust they hang in positions. Yeah. And because I mean, I honestly would say none of the above, but at the same time, B is also not very wrong. I mean, the real answer, like the proper answer, would just be. So you have stuff like a comet, right? So if you have, say, let's just make Earth, okay? So this is Earth, okay? So Earth orbits around the sun, big sun here. We orbit like so, and then we have a comet. Say the comet orbits like so. Alright, this is the comet. Having a very maybe more like so, but like yeah, you have the comet, right? And then it passes by, goes through, comes here and there, and then when it passes by, like here, it's gonna leave some stuff. Okay, so you're gonna leave some stuff, and then the stuff that it leaves will, as the Earth moves, right? The Earth's gonna move, and then these stuffs will crash into Earth because gravity and all that. So that will cause meteors to occur. And the constellation is more like something that humans made up. I mean, if you didn't know, constellation is something that humans made up, and if you didn't know also, constellations in fact refer to the area and not the constellation line, which is once again completely made up, which is why you will realize that the IAU official constellation lines for certain constellations such as Scorpius is much uglier than the Stellarium ones. I'm sorry IAU, but like yeah. Anyway, so because they originate from the same point, since it's, you know, once again they are a bunch of stuff, but they're actually in like about one region in space, so they will appear to shoot out of one specific point, and for simplicity's sake and for recognition's sake, scientists just went like, okay, so if this point called the radiant, because it's where they seem to, you know, radiate quote unquote from, it is like, we're just gonna name it after the constellation. So we have stuff like Orionids, but what really happens is just that this patch of dust and stuff that happens to be in this region of space, when they hit Earth, they just happen to originate, they seem to appear from the Orionids. So yeah, in fact I recall a few meteor showers are actually like coming from the same comet, but I forgot which ones. Let's see if Google can help me. Which comets caused meteor showers? Hopefully this is not vague and not too vague, but yeah. The Halley's Comet is Eta Aquarids and Orionids. So yeah, because like for example, taking this example, this is probably like really off for the actual orbit, but yeah, for example, this one could be the Orionids and this one could be the Eta Aquarids. But since it only shoots twice, then it's more like this. So yeah, then oopsies, then it's gonna be like this. So this one is gonna be like, say, the Orionids, and this one's like the Eta Aquarids. You know, sort of like that, if you get the gist of it. So that's like meteor showers for you, basically. And then for question 13, this one's once again a really confusing question. Okay, like look, you said latitude 45 degrees north. So do you mean you're pointing the telescope at latitude 45 degrees north? Or does it mean you're at a location that is having a latitude of 45 degrees north? But in either case, like where are you at and where are you pointing towards? You know? And then we talk about a star in a 700 mm focal length, whatever. We have 50 degrees and 10 mm eyepiece. So basically you're just saying you have a magnification of like 7 times, so the 50. But the apparent one, normally they say the FOV of eyepiece is something, and then the apparent, like if my astronomy knowledge is still astronomy, I could be wrong. I could be wrong for this, but I'm just nitpicking. Because normally I associate apparent FOV as like you already corrected for the magnification. But the value sounds like those values the eyepiece would give right out of the factory, so it sounds like it hasn't been encountered for magnification. But in either case, it doesn't really matter because the issues, there are more issues. Such as, where did my Apple Pencil go? Hilarious. Okay, I found it. Anyway. So you have that, and you take 131 seconds to pass from one end of the eyepiece to another. So you pass by, here to here. Wow. And then the closest to the center is twice as close to the left edge than the right edge. You're trying to find the declination of the star. So like you move like this, but is this north? Is this south? Am I supposed to infer this? The question now is, am I supposed to infer this? So like, it's not even specified? Basically there's a lot of things that are not specified, such as the actual magnification. I mean the actual FOV, the place that it's pointing towards, where is north, things like this. It just makes this question a bit like, therefore I'm avoiding it. This one's fun. This one's my favorite question. Not because of the people involved, but because of the nature of the question. And this one, but I like it, so we're gonna go through it later. Let's look at question 15 first, because guess what? I'm avoiding this as well. Like what do you mean by you are on a transfer orbit from Earth to Mars? Assume both orbits are circular, but what about your Mars orbit? Like what are the parameters of your Mars orbit? Like, so what if it's circular? What is the radius of your orbit to Mars? And also, what is the radius of your orbit to Earth? You didn't tell me anything. You didn't tell me anything about the orbits, aside from the fact that they're circular. But as you might know, there are many options. Like, for example, I'm here, right? Say this is Mars, okay? This is Mars, alright? And then we want to orbit Mars, which means that we want to, example, we want to orbit like this, okay? So we need to go here. So do you mean like this? The H-shaped orbit? Or do you mean like the orbit itself overlap? In this case, then like what? Basically, I have many questions. So like, I'm not doing this? And what do you mean by massless orbit? I think you mean massless satellite, but like, I mean, it does make calculations simpler, but not when you've given me so little things. So I don't know what's going on, and I'm avoiding this as well. Okay, void. So yeah, and back to question 14, which is special relativity, which is like one of my favorite astronomy stuffs. But anyway, so to solve that, we first look at decimals. Hey there, yes. So right, it was given. What was it given? Wait, actually let me take a screenshot so you can actually see the question, without like getting too much brain damage. Alright. Wait, do I really want to put my screenshot here? What was it? Oh, okay. Nothing discriminatory. Very good. Appreciate. Oh, what the hell? Cool. So we have this, right? We have it was given that it travels at some fractional speed of light, and then when it returns, how many days pass by? 5250 on his clock, but on Earth it passed by 6530. So basically we can come up with this equation, is that 5250 is equivalent to 6350 over this, which is like the Lorentz factor, or multiplied by this. So we can rearrange the equation, and we're basically gonna get this. So we move it below and we get this, right? And then we just expand, and then we just rearrange. We move this over here, and then move this over here. But I didn't put it that way, so cope. And then after doing that, we just move the c square over so we can take out the v, and then we take a square root, and then bam, we get the answer, which is 178300000, which is otherwise just 1783000 km per second. Nice, right? So it's just, C, yeah. And that is like about it. except I haven't done this. Let me use my brain to brain. They're separated by the root of this per 1. Interesting. Okay, no, I know the normal way is you use the sign or something as like the standardization metric and find the intensity, but is there no better way I can do it? 4.83, right? That's for the sun. One solar luminosity is 4.83, which is is this the solar luminosity? Yeah, sure. I don't know why that's a pop-up, but sure. Solar luminosity. Yeah, thank you for telling me it's 1L. No shit, Sherlock. Okay, it's 3828. Oops, 3828. My bad. Okay, fine, we're using that. I think its absolute magnitude is 4.83. Is this even correct? Fine, we're doing it the stupid way. Yeah. Okay, cool. So only 4.83 is this much. I mean, another star is 4.88. So given that, we basically just know that 0.05 is equivalent to yeah. Okay, cool. We can do math. Yeah, I definitely know what the hell's going on here. Okay, great. My last brain cell is really forgetting what I wrote. 10 to the power of... I guess we'll just use intuition to figure it out. 0.05 over 2.541. 1.04, so it means that thing is 1.04 the luminosity of the sun. So it means small star. This one's the bright star. We should call it D. Dim star and bright star. And then we have power here. So we have what, 4.83 minus 2.16. Bro. Okay, I guess I'm missing a bracket. Whatever. 2.16, right? So we get this. And this is a lot. Is it supposed to be this one? Oh wait, yeah, it is. Okay. Yeah, because I'm missing the factor of 2.511. Yeah, okay, that makes much more sense. So we have this much, and then we add them together, and then we have D plus B with what, A equals D plus B, and then we should say S because the sum is the bright versus dim, and then we have the you convert it back to the scale. How do we do it again? So it's 12 times the luminosity of the sun, which is 3.828 times 1226 S, which if you put over by the luminosity of the sun, no, it's just 12, Are you stupid? Yeah, just 12. So we take like what, log 12? Log S, like 1.1, you get like 2.511 log S equals to this much. Take 4.83 minus, this is what the final resultant magnitude, then we should call it R. minus r, and then you get 2.065, which is 2.07, which guess what, it's just c. There you go. Wait, let me check. Okay, the video's basically done. You can like click out now, but in the meantime, let me just see if there's some better way to do this without going through so much brain damage. Is there another way to do this? We have 2.16, then we have 4.88. So this is the dim star. Wait, no, this one's the bright star, what am I saying? So this is the dim star. And we know that the relationship between them is like, which is, and in other words, we just know that if we want to move up the scale, we can round, right? Because 4.88 minus 2.16 is equivalent to like, what, like 2.72, right? 2.72 is like about 3, kind of, no, not really about 3, but I think we can just do this, okay? This means that this thing is 2.72 times brighter than them. But we still need to add itself. Because it itself is 1 unit. One goes here. So 13.23. 13.23. So we're left with 13.23, so we know that's 13.23 times the original brightness. So if we want to convert it back, we need to like this and take 2.816. Yeah, okay, this works. Okay, great, fantastic. Yeah, so you can do this as well. Except this time you actually round down, but like, oh well. I mean, if I added 2, no, okay, fine. Oh man. But yeah, this is much better. Lol. Okay, yeah, great. So that's about it. Because it's New Year's, I will actually be posting another video soon, talking about some nice nebula DSOs, you know. So yeah, you can watch that as well if you're interested. But aside from that, that's about it for today. Thanks for watching, and hope to see you guys soon. Bye.